Welcome back, everyone. Today we're going to discuss about rational functions, particularly finding the horizontal and vertical asymptotes. Things to remember. For the horizontal asymptote, the first thing is when the top degree is less than the bottom degree, your horizontal asymptote will always be y equals 0. Number two, when the top degree is equal to the bottom degree, so you just take the coefficient of those degrees and that will be your asymptote. So y equals the coefficient of the degree on top over the coefficient of the degree at the bottom. Number three, when the top degree is greater than the bottom degree, there's just no horizontal asymptote. For the purposes of this video, I'm just defining degree as the highest power of x since we are just using x as our variable for all the examples. FYI, okay? The degree of a polynomial is another big topic. So please, just for the purposes of this video, we are just defining it as the highest power of x because that's all I'm using. Now, for the vertical asymptote, what you're going to do is to simplify your rational expression by factoring out whatever you can factor and then setting the denominator equal to 0. Example number 1, 2 over x minus 3 can actually be expressed as 2x to the 0 over x minus 3. Let's take a look at the top. The degree is 0 because the highest power of x is 0. Here at the bottom, the highest power of x is 1. Therefore, the degree of this is 1 and this on top is 0. Because the degree on top is less than the degree at the bottom, then we will follow this rule, which is that your horizontal asymptote is y equals 0. All right, now let's take a look at the vertical asymptote. So, if I set this to 0, if I set the denominator to 0, the value that will make it a 0 is x equals 3. This becomes a 3. 3 minus 3 is a 0. Therefore, your vertical asymptote is x equals 3. Setting the denominator to 0, so this is the work in order for you to get the vertical asymptote. So x minus 3 equals 0. Add 3 on both sides in order to isolate the x. So this cancels out and your x is equal to 3. Now let us confirm all these by using a graphing calculator. All right, so this is the graph of your function, and this is your horizontal asymptote y equals 0. And this green line is your x equals 3, which is your vertical asymptote. Example number 2, x squared minus 9 over x squared minus 25. Okay, so the degree of your numerator is the highest power of x, which in this case is 2, and the degree here in the denominator is also 2. So as you can see, this is rule number 2, wherein your degrees are equal. If the degrees are equal, all you will do is to get their coefficients, which is this is a 1 and a 1. So your horizontal asymptote is y equals 1 over 1 or 1. All right. Now our next thing to do is to get the vertical asymptote. In this case, we're going to simplify and we're going to factor out whatever we can factor out. We can use the difference of squares here because this is a perfect square and that's a perfect square and this is minus in the same way as the denominator. All right, now let's see if we can cancel out something. I don't see anything that I can cancel out in the numerator and in the denominator. And so we are going to just solve for the x that will make this become a 0, the denominator. Okay, so here we're going to subtract 5 on both sides to be able to isolate the x. And on this one, we're going to add 5 on both sides in order to isolate the x. So these are additive inverse and will become a 0 now. And then here we will add 5 on both sides. So in this particular example, you have two vertical asymptotes. We're now going to go ahead and use a graphing calculator to confirm all these asymptotes. All right, so this is your function, and here is your y equals 1, which is your horizontal asymptote, and your x equals negative 5 right here, and x equals 5, which are your vertical asymptotes. Example number 3, 2x squared minus 12x plus 16 over x squared minus x minus 12. As you can see, the degree of the numerator is 2. That's the highest power of x. And the degree in the denominator is 2. Therefore, they're equal. This is rule number 2. which means that your horizontal asymptote is equal to the coefficients of those degrees. Therefore, the horizontal asymptote is y equals 2 over 1 or 2. All right, the next thing that we're going to do is we're going to factor this out and simplify as best we can in order for us to get the vertical asymptote. Let's do it. Okay, so for this particular factoring, I have used the factoring by grouping, which I have a video on. Please visit my channel in order for you to see the how to factor a trinomial. Here I have just used trial and error, and we are still gonna further simplify this. All right, so I simplified and I copied it down here. So now based off of this, we can cross this out and cancel it out. All right, so before I go into the vertical asymptote, I would like to explain to you what had happened whenever we cancel this out. It created a hole. It's called a hole. So what is a hole and where exactly is this hole found? Set your x minus 4 equal to 0 and then solve for x. In this particular case, I have used a shortcut, which is to take the negative 4 from the left side, move it to the right side, and when that happens, you are changing the sign. So you can do that. That's a shortcut. So x now is equal to, take the negative 4, move it to the other side, so x equals 4. It created this right here, created a hole at x equals 4. What that means is that 4 is not part of your domain. Now, why can't it be part of your domain? If it's 4 here, then your denominator becomes 0, and that is undefined. So therefore, 4 is not part of your domain, and it's called a hole, which I'm going to show you later in the graph. All right, now let us solve for the vertical asymptote. So take the denominator x plus 3, set it to 0. Can do now the shortcut, which is take the positive 3, move it to the other side. It will become a negative 3. Therefore, your vertical asymptote is x equals negative 3. Let us now take a look at the graph. All right, so this is your function represented by the green line, and then the horizontal asymptote is the purple line, which is y equals 2, and the vertical asymptote is x equals negative 3, which is represented by the dotted red line. Now, I want you to look at something amazing that's going to happen. We will look for the hole, which is the x equals 4. I want you to focus closely. There you go. Can you see that it became a hole? And it says that 4, when it is a 4, it is undefined at that point. Therefore, you can clearly see that 4 is not part of your domain. Last and final example, x squared plus 1 all over x. Let's take a look at the degree. So on top, your degree is 2, and the bottom, your degree is 1. So clearly, this is that the numerator has the higher degree than the denominator. So in this case, according to that third rule, there is no horizontal asymptote. All right, now let us look for the vertical asymptote. We can get the vertical asymptote by setting x equal to 0. By the way, yeah, before you do that, make sure that you factor out whatever you can factor out, and as you can see, this cannot be factored out. These are both prime. So that's a prime number, this is prime. So now we are just going to set the x in the denominator equal to 0. And now we're going to use a graphing calculator to confirm all these. Okay, so this is your function x squared plus 1 all over x. So it's represented by the black graph. The red one is your vertical asymptote. So x equals 0. So there is a vertical asymptote, but there is no horizontal asymptote. So let me make that clear. There is no horizontal line that your graph tries to approach and get very, very close to. None. Okay. However, as you can see, there is an invisible slanted line, which is the oblique asymptote. In this particular case, yes, there is an oblique asymptote, which is a totally different lesson. So again, that oblique asymptote is also called the slanted asymptote. So there you go, guys. I hope that this video has helped you, and I will see you back in some other videos.